History of computer technology. The history of computers began with the invention of Chinese abacus, which was also known as counting frame. It is a calculating tool in ancient periods in China, Russia, Europe, a century before the adaptation of Arabian numbers. The history of computer technology also includes the discussion of mechanical, analog, and digital computers. At last, digital computers proved to be more powerful in economical and scaling processes in order to do large-scale computer programs. The digital computers now dominate the computer world in all areas ranging from hand calculators to supercomputers. Based on generation, they are categorized of their improvements based on hardware and software in different technology adopted are mainly used here. Mechanical era 1623. The idea of using mechanics to solve mathematical problems can be traced out at least in the 17th century. Mathematicians who designed and implemented calculators that were capable of addition, subtraction, multiplication, and division. The first multi-purpose programmer computer must be Charles Babbage's difference engine, which was an automatic mechanic calculator designed to tabulate polynomial functions. Its name is derived from the method of the division difference, a way of interpol or tabulating functions by using a small set of polynomial coefficients. There was also another machine designed by Charles Babbage that was the analytical engine was generally proposed to be fully programmable, controllable, automatic, mechanical digital computer. It would be able to perform any calculation set before it. There was no evidence that anyone before Charles Babbage had ever conceived such a device at the time, but he was not able to complete his project. The fact was that the technology at that time were not reliable for his ideas. In the 17th century, a machine was made by the inspiration of Charles Babbage's difference engine. George Schutz and his son, Edward Schutz, had begun a work on a small version of difference engine, which could process. Their machine had won a gold medal in an exhibition in Paris in 1855. Later they sold to the Dolby Observatory in Albania, New York, which was later used to calculate the orbit of Mars. One of the first commercially used mechanic computer was the US Census Bureau, which used punch card equipment designed by Herman Hollerith to tabulate the data of the 1890 census. In 1911, Hollerith Company merged with a competitor and founded the corporation of IBM, International Business Machines, in 1924. First generation computers. The period of the first generation was from 1946 to 1959. The computers of the first generation used vacuum tubes as the basic compounds of memory and circuitry of the CPU. These tubes, like electric bulb, produce a lot of heat and insulation. Used a fuse frequently, therefore, they were very expensive and only large organizations were able to afford it. In this period, mainly batch processing operating systems was used. Punch cards, paper taps, and magnetic tapes was used as input and output device. The computer in this generation used machine codes as the programming language. The main features of the first generation are vacuum tube technology, unreliable, support machine language only, very costly, generated a lot of heat, slow input and output, huge size, need of AC, non-portable, consumed a lot of electricity. The first general-purpose programmable electronic computer was the Electronic Numerical Integrator and Computer ENIAC, built by J. Presper Auckert and John V. Mauchly at the University of Pennsylvania. Work began in 1943, funded by the Army Ordnance Department, which needed a way to compute ballistics during the World War II. The machine wasn't completed until 1945. By then, it was used extensively for calculation during the designing of the hydrogen bomb. By the time it was decommissioned in 1955, it had been used to research on the designing of wind turbines, random number generation, and weather prediction. Auckert and Mauchly and John von Neumann, a consultation of the ENIAC project, began work on a new machine before ENIAC was finished. The main contribution of EDVAC, the new project, was the notion of storage program. ENIAC was controlled by a set of external switches and dials. To change the program required physical alteration the settings of these controls. These controls also limited the speed of internal electronic operations. Though the use of memory that was large enough to hold both intellectual and data, the use of programs stored in memory to control the order of arithmetical operations. EDVAC was able to run order of magnitude faster than ENIAC, but stored instruction in the same medium as data required could contribute on the improvement of internal structure of the machine without worrying about the matching it to the speed of external control. Software technology during this period was very primitive. The first programs were written out in machine codes. Programs directly wrote down the numbers that corresponding to the instructions they wanted to store in memories. By 1950s, the programmers were using a symbolic notation known as the assembly language, the hand translation of the symbolic notation into machine codes. Later, programs known as the assembler, performer, and translation task. These first electronic machines were quite useful in applied science and engineering. Other examples of the first generation are UNIVAC, IBM 650, IBM 701. Second generation computer 1959 to 1965. The second generation saw several important developments in all levels of computer system design technology used to build the basic circuit programming language used to write scientific applications, etc. The period of the second generation was from 1959 to 1965. In this generation, transistors were used that were cheaper, consumed less power, more compact in size, more reliable and faster than magnetic disks. These generation magnetic cores were used as a primary memory and magnetic tapes and magnetic disks as secondary storage devices. The main feature of the second generation are use of transistors, reliable in comparison to first generation computer, small size as compared to first generation computers, generate less heat as compared to first generation computer, consume less electricity as compared to first generation computers, faster than first generation computer, still very costly, easy required, supported machine as assembly language. Electronic switches in this era were based on discrete diodes and transistor technology, which is switch time is approximately 0.3 microseconds. The first machine to be built in this technology include Pradic, a Bell Laboratory in 1959, and TX0 at MITx Lincoln Laboratory. Memory technology was based on magnetic codes which could be accessed in random order as opposed to mercury delay lines in which data was stored as an acoustic waves that passed sequentially through the medium that could be associated only with the data moved by IQ interface. During this second generation, many high-level programming languages were introduced, including Fortran in 1956, Algol in 1959, and COBOL in 1959. Important commercial machines of this era include the IBM 704 and its second generation also saw the first two supercomputers designed specifically for numeric processing in scientific application. The term supercomputer is generally reserved for a machine that is an order of magnitude more powerful than other machines in this era. Two machines of the 1950s derived this title. The Livermore Atomic Research Computer LARC and the IBM 7030 were early examples of machines that overlapped the memory operations with processors operation and had primitive forms of parallel processing. Some computers of this generation are IBM 1620, IBM 7094, CDC 1604, CDC 3600, UNIVAC 1108. Third generation computers 1965 to 1971. The third generation brought a huge gain in computer power. The period of the third generation was from 1965 to 1971. The computers of the third generation used integrated circuit ICs in place of transistors. The single IC had many transistors, resistors, capacitors along with the associated circuits. The IC was invented by J. Kilbride. This development made the computer smaller in size, reliable, and efficient. In this generation, remote processing, time-sharing, multi-programming operating systems were used. The main feature of the third generation are IC used, more reliable in compared to the previous two generations, small size, generated less heat, faster, lesser maintenance, still costly, easy required, consume less electricity, support high-level languages. The first ICs were based on small-scale integration SSI circuits, which had about 10 devices per circuit. They evolved with the use of medium-scale integrated MSI circuit, which had up to 100 devices per chip. Earlier in the third generation, Cambridge University and the University of London cooperated in the development of CPL, Combined Programming Language, in 1953. CPL, associated to its authors, was an attempt to capture only the important features of the complication and of the Algol. However, Algol CPL was large with many features that were hard to learn. In an attempt to further simplification, Martin Richards of Cambridge developed a subset of CPL called the BCPL, Basic Computer Programming Language, in 1957. In 1971, Ken Thompson of Bell Labs developed yet another simplification of CPL called the P. Is connected with the early implementation of Unix operating system. Some computers in this generation are IBM 360 series, Honeywell 6000 series, PDP, Personal Data Processor, IBM 370 and 168. Fourth generation computers, 1971 to 1980s. The period of the fourth generation was from 1971 to 1980s. The fourth generation of the computer saw the use of large-scale integrators, LSI, 1000 devices per chip, and very large-scale integrators, VLSI, 1 lakh devices per chip, is a construction of computer elements at the scale of entire processors will fit into a single chip, and for simple systems the entire computer can fit in one chip. The main features of the fourth generation are VLSI technology used very cheap, portable and reliable use of PCs, very small size, no AC required, concept of internet was introduced, great development in the field of network, computer became easily available. Two important events marking the early part of the third generation, the development of C programming language, the Unix operating system, both at Bell Labs. In 1972, Dennis Ritchie seeks to meet the design goals of CPL and generalized Thomson D developing the C language. Thomson and Ritchie then used C to write the version of Unix for the DECPDP level. This C-based Unix was soon ported in many different computers, relieving users from having their new operating systems. Even time they changed computer hardware. Unix, or a derivation of Unix, is now de facto standard or virtual in every computer system. Semiconductor memory replaces core memory in main memory in most systems. Until this time, the use of semiconductor memories in most systems were limited to register the charge. During this period, high-speed vector processors such as the Cray-1 and Cray-XMP and Cyber 205 dominated the high-performance computer scenes. Computers with large main memory such as the Cray-2 began to emerge. Development in software include very high-level languages such as FP for functional programming and Prolong programming logic. These languages tend to use declarative programming styles to oppose the imperative styles and Pascal Cs, Fortran, etc. In the declarating style, the programmers give the mathematical specification of what should be computed, leaving many details on how it should be computed to the compiler and or running time systems. An important event in the development of computer science was the publication of Lack's report in 1982. The U.S. Department of Defense (DDO) and National Science Foundation (NSF) sponsored a plan of large-scale computing in science and engineering chaired by Peter D. Lack. The Lack report started their aggressive and forces foreign intervention in high-performance computers, especially in Japan, where the sharp contrast of the absence of coordination of national attention of the United States. The report notes that the university research had inadequate access of high-performance computers. One of the first and the most visible responses to the LAX report was the establishment of NSF Supercomputer Center. Phase 1 on the NSF program was designed to encourage the use of high performance computers at America universities by making cycles and training of three existing supercomputers immediately available. Following the phase 1 stage in 1984 and 1985, NSS provided funding for the establishment of five phase 2 supercomputer centers. Phase 2 centers located at San Diego Supercomputer Center, Illinois National Center of Supercomputer Applications, Pittsburgh, Pittsburgh Supercomputer Center, Cornell Theory Center, and Princeton John von Neumann Center has been extremely successful at providing computer time on supercomputer to academic communities. In addition, they have provided many valuable training programs of having development several software packages and are available free to change. Some computers in this generation are DEC-10, Star 10000, PDC-11, Cray 1 supercomputer, Cray XMP supercomputer. Fifth generation computers 1980. The period of the fifth generation is 1980 till date. The fifth generation VLSI technology became ULSI, ultra large scale integrated technology. The result of the production of microprocessor chips having 10 million electronic components. The fifth generation computer was an initiative of Japan's Ministry of International Trade and Industry. MITA began in 1982. The creation of computers using massive parallel computer and logic programming. It was to be a result of massive government industry research projects in Japan during 1980s. Aim is to create an epoch-making computer. The supercomputer like the performance and to provide a plentiful of future development in artificial intelligence. Massively parallel is a term of using a large number of computer processors simultaneously perform a set of coordination computation in parallel. Logic programming is a programming paradigm in large bases of formal logic. Any programming written in logic programming language is a set of sentences in logical form expressing a fact that rules about some problem domain. Fact and rule about some probable dominance. AI included robotics, neural network, gaming, game playing, developing of experience systems of making decision and real life situations, natural language understanding and generation. The main features of the fifth generation are ULSI technology, development of true artificial intelligence, development of natural language processing, advancement of parallel processors, advancement of superconductor technology, more user-friendly interaction and multimedia factors, availability of very powerful and compact computers at cheap rate. Some computer types of this generation are desktop, laptop, notebook, ultrabook and Chromebook.